What's up, everybody? It's Dan from SageMathTutoring.com and back with another video, this time pertaining to some geometry concepts that have to do with secants and chords and circles and all that stuff. All right, so let's get started. Identify each line or segment that intersects each circle. Okay, so with regards to problem number 5, clearly the line L intersects the circle. Segment QS intersects the circle, and line UV intersects the circle. Okay, so that's the case with that. Let's see, problem number 6. Clearly line KL. It appears as though segment KH and line MN. Now, I think part of what the teacher is probably testing the student on is whether or not you can use the proper notation, as well as these proper symbols. For example, KL is a line, so it gets the arrows. KH is a segment, so it does not. Given the measures of the following segments that are tangent to the circle, find each length. Okay, so A, B, and BC. Okay, interesting. Following segments are tangent to the circle. Okay, so what they're highlighting is the fact that there's a circle, and I see that one of the segments is called AB, another one is called BC, and that means that they share point B in common. And what that means is that whatever is shared in common is the point that's kind of off to the side. And then you could sort of draw the segments. This one would be AB, and this one would be BC. Okay, so it's the case that AB is 9x minus 2. It's the case that BC is 7x plus 4. And let's see, it's true that two segments tangent to a circle from the same exterior point means that these segments are congruent. So we can set up an equation where we set these equal to each other. Okay, and then you would subtract 7x from both sides. And then you would add 2 to both sides. And then you divide both sides by 2. So we know that x is 3, but we're not done because at the end of the day, they say find AB. Well, AB is 9x minus 2. So this is going to be 9 times 3 minus 2, which is 27 minus 2, which is 25. All right, so that's how you would do that. Problem number 8, problem number 9, and 10 appear to be the same. Okay, so it's going to be the same process. Obviously, this one's a little trickier because it's got decimals in it, but nonetheless, the process in general is the same. Okay, looking at this one, finding each measure, the measure of arc KM, Well, let's see. Where's K? All right, K is right there. So arc KM would be this right there. Okay. Now, if we want the measure of arc KM, well, the real question, at least for now, is what is this angle? Because the bottom line is the arc measure is going to be equal to this angle measure. All right, because that's a central angle. It's not an angle that's back here, but it's an angle that's positioned at the center. So there's got to be a way of finding the question mark. Well, it turns out my student is pretty good at this. I noticed that you have vertical lines here, which means that if that's 51, then the question mark also has to be 51. So I think it's pretty clear that that's 51 degrees. Therefore, Km is going to be 81 degrees, which is a result of adding this 30 degrees plus the 51 degrees. So that should make sense. Look at problem number 12, HMK. HMK. Okay, so You're being tested on the ability to know that this arc measure is 180. So this whole sort of HMK thing is going to be the 180 plus the extra 30, which is 210. Okay, so that's that. Looking at problem number 13, the measure of arc JK. JK, that's right here. So it's the case that the entire blue arc is 180. So it should be clear that 51 degrees plus, let's call this x, plus x plus 30 degrees is going to equal 180. Therefore, it's the case that 81 degrees plus x equals 180. Subtracting 81 from both sides will give us x equals 99. So then we're done because ultimately they wanted the measure of arc JK, and the measure of arc JK corresponds with this angle. We chose to label this angle x, and we just found x. X is 99. Okay, so that's that one. With regards to problem number 14, MJK, right. So with regards to MJK, we are looking at the arc that goes from here through J and then ends on K. All right, so notice the order matters. Whenever they have a letter that's in the middle there, that means you must pass through that before you get to K. So it's like a major arc. It goes like that. So clearly, we already know that this right here is 99, and I think we can also agree that this green arc is 180. So it's going to be this green arc of 180 plus 99 should give you the whole thing, right? So 180 plus 99 is 279. All right, so with regards to problem number 15, if you want to find ST, well, first of all, anytime you have a circle and you have a radius and you have a chord, and the radius just so happens to cut through the chord in such a way that forms 90 degrees. So in other words, it is perpendicular to a chord that's sort of on the inside of the circle. Whenever that's the case, that means that this segment is going to be equal to that segment. Okay, so they want ST. Now we know that this green part is equal to 4. We know that this red part is equal to 7. And my student's pretty good at this, I noticed. It's going to be a matter of sort of taking into account this yellow one. And the reality is that if from Q to R it's 11 total units because 7 plus 4 is 11, then it means that this right here, this sort of yellow imaginary line that we just chose to draw, well, that's going to be 11 as well because that's the radius also, right? And then we therefore have a triangle, and that triangle happens to be this 7 right here and 11 right there. I'll continue to sort of color code it. And then we need to figure out, what is this one? And we could just call that X for now. And I think everyone would agree 7 squared plus x squared equals 11 squared. After solving for x, you would realize it's approximately 8.5. Okay, 8.5. Now, if that's 8.5, then that means that only this little part is 8.5. That's what we just found. So if we want to know what this whole thing is, it's going to be 8.5 times 2, which is 17. All right. Once again, we found this little guy, which is 8.5, and that's 8.5 as well. So clearly the whole thing has to be 8.5 times 2. All right, looking at problem number 16, we want CD this time. Well, it's kind of a weird situation where this red part is 25, 2.5, but that means that this is 2.5 because we see these tick marks here. So that's not always going to be the case that these are equal to each other. But apparently in this particular problem, this red part is also 2.5. At the end of the day, they want CD. So we know that the radius is going to be 5 total units because the distance from the center to this point is a total of 5 because it's 2.5 plus another 2.5. Let's work with this blue one. And we know that that has to be 5 units long. And my thought is let's find x because we know that if we found x right here, this thing, then if we want to know what CD is, all we would have to do is double that. So therefore, we're looking at the Pythagorean theorem, 2.5 squared plus x squared equals 5 squared. And if you solve for x, that would become approximately 4.3. Now, we're not done yet because all we've done is we've discovered that this part is 4.3. So if we want to know what the entire thing is, that's going to be 4.3 times 2, which is 8.6. All right, so that's that. Okay, sector area over the area of the entire circle will always equal the central angle measure over 360. Now, that's going to be an important formula for us to use right now. Find the area of each sector, give your answer in terms of pi, and round it to the nearest hundredth. All right, so we want to know this green sector. Well, we know it's going to be x because we don't know the actual sector area, but it's going to be over pi r squared. Now we have the radius, it's 12, so it's going to be pi 12 squared, all over, so the central angle right here would have to be 30 degrees because the arc measure is 30 degrees. So that's 30 over 360. It's the case that you could cancel the zeros. You could also turn that into a 1 and turn that into a 12. So at the end of the day, we're really looking at x over 144 pi equals 112. Therefore, x equals 144 pi over 12, aka 12 pi. Okay, now how did I get that? Well, I multiplied both sides by 144 pi, just to be clear. All right, that's what I did, and these canceled, and then I moved on to the next line because all that was left over was x. All right, so that's the answer to that one. That is the sector area, and all we've done is we've used this formula. All right, now looking at 18, once again, we're trying to find the sector area, so it's going to be x over pi times r squared. R happens to be 1. The central angle is, of course, 90 over 360. That would turn into 1/4. We would have x over pi equals 1 over 4. If we multiply both sides by pi, then these would cancel. Next thing you know, you have x equals pi over 4, and then you're done. Okay, looking at problem number 19. Find each arc length, give your answer in terms of pi round to the nearest hundredth. Okay, so GH, that's going to be this right here. Now they want the arc length, so this is a different concept. Arc length over the entire circumference, which is 2 pi r, will equal the central angle over 360. So notice how this side of the equations for sector area and arc length, this side is the same, okay? What's different is that you have the unknown over the area formula, and this is the unknown over the circumference formula. So that's important when it comes to finding GH. Well, we know that the central angle measure right here would have to be 160. So if we actually want this length, like the length of the blue arc, well, that would be x over 2 times pi times whatever the heck the radius is. Looks like the radius is 18, and that's going to be equal to 160 over 360, both divisible by 2, that's 80. That would become 180, that's divisible by 2 as well, probably 4 actually. But if you divide it by 2, it'd be 40, that'd be 90, divisible by 10, you would have 4 over 9, so it's kind of ugly, but we're going to work with it. We have x over 2 pi 18 is really 36 pi, and that equals 4 over 9. In order to solve this, you can multiply both sides by 36 pi and cancel. Next thing you know, we have x equals, and this would become 16 pi after simplifying it all. All right, so that's that one. Looking at problem number 20, M and P. So they want the actual length, not the arc measure, but the actual length of this huge arc right there. Okay. Now, let's see. They say that, I guess, arc MN is 270. No, that looks like 180. Yeah, so apparently the arc measure is 270, but that's not to be confused with the arc length. If we were to draw this sort of angle here, we know for a fact, due to the fact that the arc measure is 270, that this sort of huge angle is 270, and that's enough information for us. So we would simply rely on the arc length formula. We would simply rely on this arc length formula again. So we're looking at x over 2 times pi times the radius. Looks like the radius is 2 equals the central angle, which is 270 over 360. 27 over 36, 9 over 12, 3 over 4, I believe. So that's 3 over 4. So we're looking at x over 4 pi equals 3/4. Multiplying both sides by 4 pi, x would therefore be 3 pi. And that's the length of that green arc right there. Okay, inscribed angles, problem number 21. Find each measure, the measure of JL. Let's see, so JL is right here. So that's going to rely on this structure that says that this angle of 82 will be half of the measure of the sort of intersected arc. Now remember, we're talking about the measure of the arc. We're not talking about arc length. We're talking about arc measure. It's also the case that arc measure is going to be a degree measure. It's also the case that this 82 degrees is not positioned at the center, okay? The 82 degrees is positioned all the way at the opposite edge, which means that it has to be half of whatever the arc measure is. So if we want the arc measure, I think it makes total sense that we would multiply 82 by 2. 82 times 2 is 164 degrees. All right, what about the next problem, which says the measure of MKL? So MKL is, first of all, an angle, so it's going to be this angle right here. Okay, so it intersects an arc that has a measure of 64, so this angle must be half of that, which is 32. Okay, looking at 23, find each value. Okay, well, clearly this red angle is sort of intersecting this big arc here. Now, the measure of this big arc is clearly 180 degrees, and the way that I know that is because the central angle is 180 degrees. The central angle is 180 degrees, which means that this arc measure needs to be 180 degrees, which means that this angle that's sort of all the way across has to be half that, which is 90, which means we could set 3x plus 12 equal to 90 and take it from there. 3x plus 12 equals 90. Subtracting 12 from both sides would give me, I believe, 78. That would be 26, I believe. Let's see. Yes. So x is 26, and that's what they want. So we are done with that one. All right, looking at problem 24. So problem number 24 says find angle RSP. RSP. Okay, so it's the case that RSP is clearly going to be half of this arc measure. Now, we'll call this arc measure X. So let's say that. Let's say that the angle measure of RSP, which is 3y plus 3, that is going to equal 1/2 of whatever the heck X is. Now, we have other information that pertains to this blue angle, which also intersects this arc. And the blue angle measure is 5y minus 21. And we know that 5y minus 21 would also be 1/2 x. So the reality is that this is equal to this thing, right? This is equal to the same thing. So by the transitive property, I believe, these would have to be equal to each other. All right, doesn't that make perfect sense? So we can set up an equation that says 3y plus 3 is equal to 5y minus 21. Subtracting 3y from both sides gives me 2y. Adding 21 to both sides gives me 24. Y clearly equals 12. We're not done yet, though, because they don't want y. They want the measure of angle RSP. They want the measure of this red angle, which is 3y plus 3. So that's going to be 3 times 12 plus 3. 3 times 12 is 36. 36 plus 3 is 39. So it is 39 degrees. Okay, looking at this one. Problem number 25. The measure of MR, arc MR. Okay, let's see. We're looking for the measure of this, right? Well, that's where really this is going to come into play. Anytime you see this pattern where you have one tangent sort of ray here and you have a secant ray cutting through, it's the case that this angle that's being formed will always be 1/2 of this intercepted arc. Now, we know that the angle that's being formed, like if you look very closely at the diagram, right, kind of see what's going on here, we know that the angle that's being formed is really this angle, this red angle here. That's 41, okay? So we know that that's going to be half of whatever this sort of green arc measure would be. So therefore, that green arc measure is going to be 2 times 41, okay? 2 times 41. So that's clearly 82. So that's the answer, 82 degrees. Problem number 26. Now we want the measure of QMR, and that's an angle, QMR. So we want this, right? We want that. Well, we already know that this blue arc measure is 120. We already know that this green arc measure is 82, right? We found that. So this yellow arc measure right here, which we'll sort of call X for now, is going to be the result of solving the following equation. We know that 120 degrees plus that 82-degree arc plus x degree arc is going to equal 360 all the way around. 120 plus 82 is 202 plus x equals 360. 360 degrees minus 202 is 158, I guess, right? So it's the case that the arc measure here is 158. So if we want this angle right here, we know that that's going to be half of 158, and half of 158 is, let's see, 50 plus 25 plus 4. So 50 plus 79. So that's going to be 79. All right, looking at problem number 27. So that has to do with this one, where basically the angle right here, this angle 1, it happens to be equal to angle 2, first of all, right? Because they're vertical angles. But when you only focus on angle 1, you could say that it's going to be half of the sum of this arc plus this arc. So my student's pretty good at it, recognizing that if we want to find the angle measure of GKH, which is this, well, first of all, let's just call it x. And we can say that x is equal to 1/2 times the entire sum of 41 plus 93. 41 plus 93 is 134, and 1/2 of that is 67. Okay. So for my student watching, just know that this parentheses, you can actually simplify this according to PEMDAS first, before you worry about multiplying by 1/2, because we can actually find out what 41 plus 93 is. It's 134. If there was a variable here, there'd be a different story. For example, if it was x plus 93, well, then you would have to distribute the 1/2. 29, a piece of string art is made, blah, 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 16 around. A piece of string is wound from A to B to C to D. Okay, so from A to B to C to D. Got it. What is the measure of B, X, C? Right. Well, we know that the arcs that correspond with the situation are those arcs, right? And I'll just call this theta. I'll use a theta symbol this time, representing the answer we are trying to find. Now, we know that it's 16 sort of intervals all the way around. So I feel like what that means is we could figure out what the degree measure is of just one of these, right? By taking 360 and dividing it by 16, and that is 360 divided by 16 is 22.5. So it's the case that each of these is 22.5. So how many of those intervals do we have in this arc? Well, it'll be 1, 2, 3, 4, 5, 6. So the entire arc measure is going to be 22.5 times 6, which is 135. All right, 135. The entire arc measure over here is going to be 22.5 times 2, which is 45. So then we could just use that formula that we already know that says that theta would therefore be equal to 1/2 of 45 plus 135. And 135 plus 45 is 180. So theta is going to equal 1/2 of 180, which happens to be 90. Okay, so that's how you do that one. Okay, so looking at problem number 29, find the value of the variable and the length of each chord. So this problem number 29 takes advantage of this particular theorem that says that anytime you have this sort of crisscrossing, it's going to be the case that AE times EB, which is this part, is going to equal CE times this part. Okay, so therefore, I think we can see that with regards to problem number 29, that 3y is going to equal 7 times 5. Therefore, 3y equals 35, and therefore y equals 35 divided by 3, which is awesome. Okay, so that's the case with that. 35 divided by 3 happens to be what? Let's see. That's going to be 11, approximately 11.7. So they don't just want the variable, right? They want the length of each chord. So we already know the length of DE. DE is clearly 7 plus 5, which is 12. BC is going to be y plus 3. We already know what y is. It's 11.7. So that's going to be 11.7 plus 3, which is 14.3, or 0.7 rather. Okay, so that's that one. Looking at problem number 30. Problem number 30, it would be 15 times 8 equals 10 times z, and 15 times 8 is, well, that would be 30 times 4, which is 120, which is 10 times z. Dividing both sides by 10, z would therefore be 12, and with regards to the length of this chord, we already know that that's going to be 15 plus 8, which happens to be 23, and when it comes to the length of this chord, it's going to be 10 plus c, and therefore 10 plus 12, and therefore the length of chord RQ is 22. All right, so that's that one. Find the value of the variable and the length of each secant segment. So these problems are going to take advantage of the theorems over here. I feel as though, in a sense, both of these are sort of saying the same thing. Now, the way to read it is that the whole thing, just the outside part, is going to equal this whole thing times the outside part. So for my student watching, it's like that kind of a pattern where it's this whole thing times just the outside part is going to equal this whole thing times just the outside part. Now, this is essentially saying the same thing. It's this whole thing times the outside part is going to equal this whole thing times the outside part, which is just itself, right? So you can see that DC is being squared here. Okay, so this guy is being squared. For me, it's sort of the same thing. Okay, so amazing. Let's take a look at problem number 31. Value of the variable and the length of each secant segment. So it's going to be this whole thing, which is 6 plus 4 times the outside part, which is just 6, is going to equal the whole thing on the other thing, which is 5 plus x, times just the outside part, which is 5. Now we can distribute. In this case, we should well, actually, we should not distribute here, right? Because 6 plus 4 is just 10, and 10 times 6 is, of course, 60. We should distribute on the right-hand side, so that's going to be 25 plus 5x. Subtracting 25 from both sides would give us, I guess, 35, right? and then dividing both sides by 5 would give us 7. So x equals 7. They don't just want the variable, though. They want the length of each secant segment. So clearly the entire length of this one is 10, and the entire length of this one would be 5 plus 7, which is 12. Okay, so that's that one. Looking at the next problem, it's going to be this whole thing times just the outside part times this whole thing times just the outside part. So once again, it's going to be, I kind of messed everything up, so let's make it so we can see. So it's going to be 4 plus y times the outside part, which is 4, is equal to 5 plus 5, because that's the whole thing, times the outside part, which is 5. This part's easy. That's going to be 10 times 5, which is 50. With regards to this, we're going to distribute. We have 16 plus 4y, subtracting 16 from both sides would be 10 minus 6 is 4, and 4 minus 1 is 3. Dividing both sides by 4 would give us 8.5. So that's the variable. Therefore, the entire chord or secant length, segment length here would be 10, and the entire secant segment length here would be 4 plus 8.5, which is 12.5. So that's one. Okay, so the equation of any circle is the following. It's going to be x minus h squared plus y minus k squared, and that equals radius squared. That's the case that the center is going to be hk, so I'll move to a c, and then the radius is, of course, going to be r. So let's be very clear that since the radius is equal to r, the radius will always be the square root of whatever this whole number is over here. Okay, so if this is a 10, then the radius is going to be the square root of that. Looking at problem number 33, write an equation of a circle A with center -4, -3, and radius 3. Okay, simple enough. So it's the case that it would be x minus a -4 squared plus y minus a -3 squared, and that's going to equal the radius squared. Now this is just going to be 9 over here, and then we could kind of clean these up to say x plus 4 squared plus y plus 3 squared, and then we're done. Okay. Looking at problem number 34, we want the equation of circle B that passes through -2, -2, and it has the center. All right, so since we have the center, which is right there, we can already begin the process of setting up the equation. It's going to be x minus -2 squared plus, we could say y minus 0 squared, and that's going to be the radius squared. Now, it so happens we don't know the radius yet, but we will soon. Let's clean this up a little bit, though. We have x plus 2 squared plus y squared, actually, right? Just simply y squared, and then radius squared. So clearly we're going to need to find the radius. We have to go on a mission to find the radius. Now, they do give us a clue somewhat in that they say, oh, well, the center is whatever, and we also know that there's some other point that's on the circle. So you don't necessarily have to graph the situation when you're doing the problem, but to illustrate what's happening, I'm going to draw the center right here, and then apparently there's this other point at -2 comma -2, which means that we have a circle that kind of goes around like that, right? Now, to be clear, it's clearly the case that it's 2 units away in the sort of southern direction, which means it's going to be 2 units away over here, which means it's going to be 2 units away over here, which means it's, of course, going to be 2 units away over here. Now, it should be obvious that the radius is, of course, 2, right? So therefore, we can update the equation to represent that fact. it's going to be x plus 2 squared plus y squared. And that's going to equal 2 squared, which is just 4. And then we're done with that. And we're geniuses. Okay, so that's that one. If it wasn't so easy, for example, I do hate to say it, but if it wasn't such that the point was directly below the center, if the point was sort of at an angle to the center, like it's easy to know the radius when it's down here or up here. But if it's here, right, then it's a little harder to find the actual length of the radius. Therefore, you would have to use the distance formula, okay, for that. With regards to problem number 35, circle C, we want the equation of that. Well, we know that the equation of any circle is what I said before, which is this, plus y minus k squared, and that's going to equal radius squared, where h comma k is the center and r is the radius. So we should find the center. The center is right there. Apparently h comma k is, looks like it's 1 comma negative 1, right? So for that reason, we could begin the process of constructing the equation, but actually let's go ahead and just find the radius as well. I feel like this shouldn't be too hard. Looks like, if we look closely, it looks like the radius is 1, 2, 3, 4 units long, right? So the r in this case is equal to 4. At that point, we officially have enough information to fill out the equation of the circle. So that's going to be x minus h, which is 1 squared, plus y minus k, so that's y minus negative 1 squared equals 4 squared, right? Let's clean it up a little bit. We have x minus 1 squared plus y plus 1 squared, and that's going to equal 16, right? And that's that one. Now they want us to actually graph something for problem number 36. So let's once again bring our graph back, and let's see. So well, HK center, right? HK is the center, and we know that we could sort of compare this to the sort of structure. So notice how h is the number that's being subtracted from x. Now, for that reason, h will always be the opposite sign of whatever that number is. Okay, now if you don't get that, it's okay. It might be at this stage in the game worth simply memorizing the fact that h will always be the opposite sign of this number. So we know that the h so far is -2. And then the k, similarly, would be the opposite sign of this number. That's like a -2, so k is going to be +2. Okay. Now, with regards to the radius is always going to be the square root of this number. So the square root of 1 happens to just be 1. So we have two pieces of information that will officially give us enough to work with if we want to graph this. The center is at -2, comma 2, so that's clearly right there. Now, with regards to the radius itself, I like to do north, east, west, south stuff. So it's a radius of 1, so it's going to be hovering above. It's going to be hovering above 1 unit. It's going to be hovering to the right 1 unit. It's going to be down below 1 unit. It's going to be to the left 1 unit, and that's going to be our circle. All right, so that's how you do that one as well. So for those of you watching, hopefully that was helpful. I know I kind of moved quickly. I don't think I made Carol's mistakes, but as per usual, there's always a chance. So you can let me know if that's the case. And good luck, everybody, and I'll talk to you later. Have a good one. Bye.